Hello, my name is Mirak Chibuzamasel, and I'm the founder and the director of the Pan-African Citizen Science E-Lab. So today we are going to be discussing on planetary choreography. So from the table of contents, I'll be touching on planetary parades, conjunction, and occultation. So just a gentle reminder that this lecture is brought to you by the Free Astro Science. So, introduction to planetary parade. Planetary parades, also called alignment or planetary alignment, occurs when three or more planets appear to line up in the sky from Earth perspective. So you can see it from our own perspective on Earth. You can say that these planets are aligned. You must have heard this from the news several for over the years, and probably you do not know what is going on. So in this lecture, I'm going to educate you on what is going on. So this alignment is not all the time a perfect circle. Sometimes they can be in form of an arc. So you can see it here. You can see Mercury, Mars, Jupiter, Uranus, Neptune, and Saturn. So sometimes they can also appear in this fine arc, not always in a perfect row like soldiers. Now, I want you to know this and take this very seriously. This alignment is a visual effect. It is just an illusion because it is not physical. It is not physical. It is not like the planets are in alignment like the way you see it in this picture. Because during this time, there's a lot of pictures that fly on the internet showing this kind of things. This is wrong. Okay, the, the planets are not aligned in this form. But these planets are just doing their thing. They are not aligned in one side of the solar system, no. They are just scattered across the solar system, moving around the sun. Just that from my own perspective, we see them in perfect in a row, okay, or in an arc. So if we were to be in another planet, if I were to be on Mars and you are on Earth and you're seeing an alignment on Earth, I on Mars will not see the alignment. Okay. But sometimes on Mars I will see some alignment, but you will not see them. So it is an illusion. It is not a physical, it's not a physical one. So the planets are still separated by millions of kilometers apart. So this picture is wrong. Is wrong because if this is true, it means that in real life there is an alignment, but there is it doesn't happen that way. Okay, just that this is a visual event. So, so this is what we see. This is what we see during a planetary parade. This is what we see in the sky with respect to our Earth. So a visual event. So types of planetary parade, we have mini parade. So mini parade involves three planets. It involves three planets. It could be Venus, Mars, Jupiter, or any of the planets in the sky. So it occurs 2 to 3 times per year. So it is fairly common. Then we have the moderate parade. It happens between 4 to 5 planets. So it occurs 1 to 2 times on the average every. Uh, it happens once every 1 to 2 years. Sorry, okay, on the average. So you have these planets, mostly those ones we can see with our eyes. Then we have the full grand parade. The full grand parade. So which involves 6 planets 6 planets. No, we have 8 planets. So this involves 6 planets. So, but this is not common. It is the rarest of them. It happens once every 20 years. So the last lunar, the last full grand or grand parade we witnessed was on June 3 to 4, 2024. So here you have 6 planets. You have Mercury, you have Jupiter, Saturn, Uranus, Neptune. Okay, although some of them were hard to find, hard to see with the naked eye. You can use telescopes for those ones we can't see. So we will also have a special type of lunar parade called the lunar planetary parade. So this involves the moon being in that parade. If the moon is involved in that planetary parade, be it mini parade or moderate parade or even the full parade, if the moon is involved in that parade, we call it the lunar parade. So the parade has a lot of scientific uh, importance. It has some scientific importance because you mostly hear this parade from astrology. Okay, but astronomy is different from astrology because astronomy is science. Astronomy is science. Astrology is a belief. Okay, so we are different. So I'm going to just give you the scientific importance of planetary parade. So, parade lets astronomers observe multiple planets at once. Okay, so that provides a quick health check on their positions and motions. Okay, so it is also useful for detecting tiny orbital deviations caused by undiscovered objects. Example, the planet X theory. So, assuming that you are looking at the parade going on, and we are looking at our orbital mechanical programming. Okay, we use computers for some of these things. We're looking at our math and our computer programming, and maybe it is not as what we expected it. So we can theorize that maybe there is an undiscovered planet out there that is causing some gravitational perturbations. So it is also good for public engagement. Okay, you bring the kids outside, you with a telescope, you show them these planetary parades to inspire them towards pursuing careers in science, technology, engineering, and mathematics. It is also good for historical validations because those people that lived in the ancient times also saw these parades and they kept the records. So if we get their records and we get our own records, we can validate each other. So we have our now introduction to planetary conjunctions. We are done with planetary parade. Now, in planetary conjunctions, when two planets or more appear extremely close in the sky, when they cluster like star clusters, like planets, that's very rare. When they cluster in the sky, within a few degrees, we call that planetary conjunction. So you can see it from this picture. You have two planets that are close by. So types of planetary conjunctions, we have standard conjunctions. So under standard conjunctions, we have just two planets appear close in the sky within a few degrees. So it could be between Jupiter or Venus. It could be other planets too. So, and they are pretty common. It happens several times per year that we have the great conjunction. So it's a special kind of the standard conjunction that happens only between Jupiter and Saturn. Anytime you hear about the great conjunction, they are talking about the conjunction of Jupiter and Saturn, just like what we saw in December 2020 during the COVID-19 lockdown. So we saw Jupiter and Saturn. We spotted the two coming together on Saturn from October, I think October, and every day people took shots. Then when you combine them together until December 21st, we saw this conjunction. So we saw that everybody saw it. This picture went so viral. So we have the triple conjunction. So we have done standard conjunction, and now we have our triple conjunction. So what is triple conjunction? You might think, okay, three conjunctions. Some people make that mistakes. When I was preparing this lecture, when I was preparing this lecture, I saw people on YouTube describing three, triple conjunction as three planets clustering together, but that's wrong. That is wrong. So triple conjunction involves still two planets, okay, but appear to meet three times in less than 1 year. So imagine you have two planets, any planet. It could be the great conjunction, just any planet. But you saw them on February, probably. You saw them also within the middle of the year and also towards the end of the year. Just 1 year coming together. We call that the triple conjunctions. So, and that is because of the retrograde motion. That happened because of retrograde motion. So it happened with a great conjunction in 1981. So you can see them. You can see uh, Saturn and Jupiter. It could be other planets. So because of this retrograde motion, it is from our own perspective. Okay. So, and also it can happen between a planet and a star. A planet and a star. It can also happen. So maybe imagine that maybe a star, this star here, and maybe a planet comes and does that, does this retrograde motion thing and goes away. So it can also happen with that. So now, so like I said, triple conjunction is not about three, 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 three planets. It's about two planets coming close together three times within a year. So what is the term for three planets or more planets that experience that cluster together? So the term we use for that for three planets is three triple planetary conjunction, or we can call it the planetary trio. So instead of calling it the triple conjunction, it is called triple planetary conjunction. So I want you to know the difference because this is the standard definition according to the International Astronomical Union. So so we have the planetary trio and the planetary quartet. So the planetary trio involves three planets within 5 degrees circle in the sky. So it is pretty frequent. It happens once every 1 to 2 years, and it happens. You can see it with bright planets like Venus, Jupiter, or Mars. So the next event is slated to happen on June 29th, 2025. So it's going to happen between Mercury, Mars, Jupiter at dawn. So you can, if you get to listen to this video before then, you can get to um, take a look. Okay, then we have the planetary quartet, which involves four planets. Okay, within 5 degrees, which is this one is more rarer. It happens once in a decade. So from this picture, you can see Jupiter, Venus, and Mars in, in very close in close proximity. Then we have Mercury separated. Assuming that this Mercury could come closer and closer, okay, it could become a planetary quartet, like this one here. So then we have the planet-moon conjunction. So for a planet-moon conjunction, when a planet appears near the moon, okay, so we call that a lunar we call it a planet moon conjunction or a lunar conjunction. Just a single planet appearing close to the moon. Now, just like this, assuming just ignore this Jupiter here, assuming that you have a planet Saturn or moon or Venus or Mercury or with the moon in the sky at dawn or night or dusk, when they appear close together in the sky, we call that planet moon conjunction, or can call it lunar conjunction. But if it involves multiple planets near the moon, maybe you have Jupiter, Saturn, okay, it involves multiple planets. So we call that the multi-planet lunar conjunction or planetary moon cluster, just like what we have here. So that gives rise to this kind of pictures, the smiley face. You see all over the internet, the smiley face. It happened, I think it happened on April. It happened on April, if I may be right. So So this is a picture, a video of someone made a time lapse of the conjunction, but he made a mistake by calling it triple conjunction, but that's not triple conjunction like what I said before. So many people are misplacing the terms. But just look at the picture. So here you have the planets, you have the smiley moon. It's a very great scene. So you don't see it. So this is it. So here are the two planets, and you have the moon. This is the moon could be in the waning or waxing phase. So it doesn't matter whether it's in the crescent or waxing phase. When you have this kind of arrangement, it's called triple. It's called multi-planet lunar conjunction or planetary lunar cluster. All right, so then we have planet-star conjunction. So this involves planets and a star. Maybe if there are planets close to the Pleiades, the Pleiades are several stars clustered together. We call that planet-star conjunction. So then conjunctions, planetary conjunctions in general have a lot of scientific benefits to astronomers and to the general public. Okay, so so if Jupiter, just imagine if Jupiter and Saturn appear to merge on schedule, okay, we say, okay, this is gonna happen by this time, just like just like when how it was predicted in the 2020, okay, so it confirms our orbital math is accurate. Do you understand? No, this is not prophecy, please. Some people think that we are prophesying. No, when these planets, we know their speed and we know their position, so you can always predict where they're going to be next. Okay, we're not making some kind of prophecy. No, some people think it's prophecy. It's not prophecy because you know why I say that? Because I used to make posts about it on my social media, and people were kind of asking me, "How do you know that this is going to happen?" I say, "Yeah, I know because I'm an expert." Okay, but this is the reason. We know their speed and their position, so we can always predict where they're going to be, even in the next 1,000 years. We know what is going to happen. Do you understand? So that's the beauty of math, and that's the beauty of science and math. So, but if there is a tiny discrepancy, just imagine that we predicted it and there's a tiny discrepancy in our prediction, or maybe how we predicted it did not match with reality, then we know there is a hidden force. Maybe there's a planet. So we start looking for it because that planet is going to cause a, a gravitational tug in the system. So we know there's a hidden world. So you see the beauty. Very, very beautiful. Very, very beautiful way of discovering planets. So they help us to study exoplanets. Okay. So when two planets uh, come close, you know, when two planets come close in our solar system, okay, so we can use telescopes like the James Webb Space Telescope to observe them at once so that we don't have to observe them separately when they are in separate positions. So we save a lot of telescope time and resources by doing that. And then we can compare the atmospheres and study them with the data we've collected. So you see how great it is. Very, very important. It saves time. Because 1 second on James Webb Space Telescope is is $60. So imagine that you're PhD researcher, you don't have a lot of resources. You just have to wait for when there's going to be an alignment or conjunction. So you just take pictures and you study your planets, okay, on budget. You study your planet on budget. So they push telescope tech. For instance, resolving two bright planets near each other tests camera resolution and adaptive optics. Okay, like focusing on two fireflies side by side. So it helps us to test our telescope. So there's also records of past conjunctions. Okay, they help us to check if orbits have changed over centuries. And also, it is important for public engagement, engaging the public in astronomy, to inspire the public towards astronomy. Then we have the occultation thing. So, what is occultation? What is occultation? What is the occultation? Now we know we have studied conjunction, so when two planets come together very, very close. Now, what if they come so much close that one hides the other? They are coming close and close and close, and maybe one hides the other. So let me just give you this picture. Let me show you this picture. that I showed you before. Now look at these two, Saturn and Jupiter. What if maybe Jupiter hides Saturn? There's come so much close that you can't see Saturn anymore. It's not because your telescope cannot resolve the two bright sources. No, it's just because one is hiding behind the other. Okay, we call that an occultation. An occultation. Probably this is your first time of hearing it. So we call it occultation. So when a nearby object, it occurs when a nearby object like our moon, okay, passes in front of a more distant one, like star or planet. We call it other occultation. So for instance, look at the simulation. So you have Jupiter here. You have Jupiter. So sorry, this is Saturn. This is Saturn. Now you have the moon, and the moon passes in front of it momentarily, blocking it. Or maybe you can have total solar eclipse where you have the moon entirely blocking the sun. So this is an occultation phenomena. Then we have this one. I'm going to explain this. This is not an occultation. So here is Earth, and here is Venus, and here is the Sun, and it's transited. This is how we view it from Earth. Sometimes um, Venus transits the sun, and we see it. We see it in this form. This is not an occultation. I'm going to explain why. It is not in the category of others. You can probably see it already, but I'm going to explain it further. So types of occultations. So we have lunar occultation. So our moon moves in front of a star or planet. So temporarily hiding it. So I've shown you these two examples. So here's another example. Maybe if you're looking at a star, you're studying a star, and the moon is blocking it. So you have to wait because it just lasts for a few minutes. So because the moon is pretty fast. So it's it's called a lunar occultation. So we have solar eclipse too. We have this one. So what are the scientific of this lunar occultation? So it is used to measure the moon's precise orbit and topography. It helps us to study atmospheres of planets. So if a planet is occulted, like that Saturn you saw, we can study the atmosphere using that occultation. Then it helps us to detect binary stars. Then we have planetary occultation. So here you have one planet passing in front of another planet. Okay, it is very, very rare. It is the most rare type of occultation. So, so the last occultation, planetary occultation we experienced was in 1818. All the generation that witnessed it have all gone by now. So in 1818, so here you have Jupiter occulting occulting Venus. But the future event, the future planetary occultation is going to be in 2065. 2065. We're in 2025. So if you do the math, that would be 40 years. 40 years from now. 2025 and 2065 is 40 years. So Venus is going to occult Jupiter. Okay, so the scientific importance of planetary occultation, so it is used to test ultra precise planetary position models, and it could review atmospheric properties if the foreground planet has an atmosphere. So then we have asteroid occultation. So here you have an asteroid blocking light from a distant star. So like you have it here, asteroid occultation. So it is important. Asteroid occultation is equally important because it is used to measure asteroid sizes, shapes, and orbits with high precision. It is used to detect binary asteroids that are in like orbiting each other. So for instance, if a star flickers multiple times, it means that an asteroid is passing and it flickers. So it means that it is it's a binary asteroid. It helps us to map star sizes since asteroids have sharp edges. Then we have the mother of all occultation, which is called the stellar occultation. So here you have a planet in our solar system, or exoplanet, or their moons, okay, or their moons blocking a star, or their host star blocks them, or their host star blocks them. For instance, if you want to look at a planet in our solar system and you can see it, it is probably in the other side of the sun. So, in the other side of the sun. So, that is called a stellar occultation. Or an exoplanet hides behind its host star. If you're looking at a star with an exoplanet and you can't find it, it is probably because it is hiding behind its host star. Then another example is lunar eclipse. So if you were an astronaut on the moon, you're on the moon. So and there's a lunar eclipse. You see that the Earth blocks the entire sun's radiation from reaching. So it's an occultation. So lunar eclipse is an occultation. It's part of stellar occultation. So here's a picture. If you're looking at a star and something just moves in front of it, it could be a black hole, it could be a planet. So it's also part of stellar occultation. And you know this is a stellar occultation because our sun is a star too, so remember that. Now, not stellar occultation, but transit. So that you don't mix them. So first of all, exoplanet transit. When an exoplanet is transiting in front of its host star, it does not entirely block the host star. It does not block it. If it blocks it, it's going to be an occultation. But for most cases, it just reduces the flux of the star. So it does not block it. But when it goes behind its host star, like you can see right now, it becomes occultation. The star occults it. But when it passes in front of its host star, it does not. It is not occultation. It does not occult to the star. So another example is annular solar eclipse. Annular solar eclipse happens when the moon is at apogee, when it is farther out from the Earth. It is apogee. It does not entirely block the sun's radiation from reaching Earth. You can see a ring of fire around it. So we call it annular solar eclipse. Call that annular solar eclipse. So that is not an occultation. In fact, we can call it a transit. So another example is planetary bodies like Venus passing in front of the sun. Right in front of the sun. It is not an occultation, but just simply a transit. Maybe if by tomorrow they begin to block the whole star, maybe I don't know how it's not going to be possible, but it's not going to be possible. So this is just it. They are just transit. They are just transit. So here's a summary of the difference between eclipse, transit, and occultation. So here you have a planet with a moon at different position. Okay, so from our own perspective, as we are looking at this moon here, it is casting shadow on its host planet. So this is an eclipse. Okay, so then as it comes to this position, it is now transiting and also experiencing an eclipse. See that? Now, when it is here, the shadow has left the surface of the planet, so it is somewhere here. So we call it pure transit, not an eclipse. And when it goes behind the host star, we call it an occultation. It becomes an occultation because the planet completely blocks it. So stellar occultation has a lot of scientific use. It is used to measure the sizes and shapes of planets and moons. It is used to detect and study atmospheres of planetary bodies. It is used for discovering rings, moons, or binary companions. It is used for mapping surface features on moons and asteroids. The exact timing of occultation helps astronomers refine the orbits of the curtain body. So thank you very much for paying attention, and if you have any question, please drop it in the comment section. We're going to respond to them in the podcast. Thank you.